everyone, welcome to Simpler Science. So today we are going to introduce the fundamental principle in the organic chemistry, which is specifically in the acid-base reaction, which is the Ka and the pKa. So before we introducing them, let's talk about the low Bronsted acid and the low Bronsted base. So acid, when you see an acid, means that it is donating the proton. And donating the proton, we can also say it is actually accepting electrons because the proton has a positive charge, right? So when it donates its proton, it will gain electrons. So we can also think of it as the Lewis base. So Lewis base means that it's actually accepting electrons. So we can use same color to make them more visualize it. And on the other hand, the low Bronsted base means that it is accepting the proton. And also it will equals to the Lewis acid. So Lewis acid basically means that donating electron. And the low Bronsted acid will form a conjugate acid, and the low Bronsted base will form the conjugate base. This will not change in any acid-base reaction. So now let's introduce the Ka. So Ka is the acid dissociation constant, which is equals to the concentration of product and the concentration of reactant. And this Ka value is important to let us distinguish which acid is more stronger than the other. So let's talk about it. So let's say the Ka value after you plug in the concentration of product and the concentration of reactant, and you get the Ka value which is larger than 1. So larger than 1 means that in the reversible reaction, the reaction pathway will shift toward the right side. And we say that anything will have its reason behind, the logic behind, right? So as you can see, if we want to get the Ka value is larger than 1, so that means that the product must be higher, right? And on the other hand, the reactant must be lower. So the product, so here is our product. So if the concentration of the product is much more higher, then you get a Ka larger than 1. So that means that your concentration of product, you have to form more product in order to get Ka, which is greater than 1. So if we interpret it reversely, then we'll get that if the Ka is greater than 1, we can say that more product will be formed, and therefore the reaction will shift to the right side. And on the other hand, if the Ka is smaller than 1, that means that the product concentration of product must be lower, and the concentration of product, the reactant must be greater, and hence the reaction pathway will shift to the left. And the explanation is basically the same, right? As you increase your concentration of reactant, that means that more concentration will be formed, and therefore the reaction will shift to the left. And so we can say that the Ka is very important to differentiate the acid strength. So the more stronger the acid, which is equals to the more weaker the base. So now let's talk about the pKa value. So pKa value is defined as the negative log of Ka, and is also used to differentiate the acid strength of different acid. So as you can see here, we have a negative sign. That means that if you increase your Ka value, because of this negative sign, you will get a smaller pKa value, and therefore we can say that the reaction will actually shift to the right side. And this is because they are equivalent, so that if you increase your Ka value, you'll get smaller pKa value. So smaller pKa value, You can also think of it as a stronger acid. So smaller pKa means that a stronger acid. So stronger acid means that it will shift toward the product, right? Because it has a Ka value greater than 1, and therefore it must shift to the right. And on the other hand, if you get a Ka value which is smaller than 1, and therefore the pKa value will be larger. The larger the pKa value, the weaker the acid strength. The weaker the acid strength, the reaction pathway will shift to the left side in order to form more reactant, right? So these two values are closely related, and it is very important to learn this, as we can use this kind of value to differentiate the acid strength, and therefore we can know the reaction pathway and as well as the acid and the base strength. So, and that's all for our video. Thank you.